Hey, what's up? Welcome to this new video. This one is paper 1-1 of October-November 2011. This is of course A-level math paper 1. Now with that being said, let's move on to question number 1. Okay, so here we have to find the term independent of x in this expansion. Now we understand that the term independent of x is a term without x. So how are we going to find this from this? So you have a few options. The first one, you can expand everything and choose the term which is independent of x, or you can choose the term directly from this expansion. For example, how would you usually expand this? You will take the power 6 combination something. Here we have 2x, and here we have 1 over x squared. Now we have to choose a power such that when you expand the whole thing, you will have a term which is without x. So again, this is done by trial and error. Now the value here, the power here can be from 0, 1, until 6. So we have to choose the number we will put on the power here. For example, again it is by trial and error. I will choose the number 2 here. If I have 2 here, this will be 2 as well. 6 minus 2 is 4. Now we can try to simplify. Now what is 6 choose 2? That will be 15. That will be 2 power 4 will be what? 16. That will be x power 4, and that will be 1 over x power 4. As you can see, these two will cancel out. So you will have what? 15 times 16, that should be 240. That will be your term, which is independent of x. Now let's move on to the next question. A curve has equation y equal to this. We have to show the gradient of the curve is never negative. So pretty easy. What is gradient of the curve? We understand it is dy by dx. Right, so let's find dy by dx. That will be 9x squared minus 12x plus 4. Now, right now we still cannot show it is never negative, so we have to think, what can we use or what have we seen before that can help us to do that? We have to kind of complete the squares. For example, before I do this, I realize I need to factorize by 9. That will be 1x squared minus divided by 9, that should be 4 over 3x, and then I can just leave this one outside, plus 4. Now because here we have 1, we can proceed to the next step. That will be 9. Here we have 1x squared minus 4 over 3x. Now we have to add something. We'll take the value here, divide by 2 should be 4 over 3, divided by 2 should be 6. That should be square, and since we add something, we also have to minus the same value. That should be 2 over 3 square. Because it was inside of the bracket, we also have to give it the value of 9. So let's see what happens now. Here we have 9, and all this will reduce to what? Here we have x, here we have minus, inside we have 2 over 3, and here we have square, plus 4 minus, that should be 9, 4 over 9. That will be cancelled out. 4 minus 4 is 0. So you will have 9 x minus 2 over 3 square. Now you can see clearly now dy by dx is equal to this. Now we understand that when you square something, it will never become negative. You can say, because we understand that x 2 over 3 will always be more than 0 or equal to 0. So we understand dy by dx, which is equal to 9 times this thing, because 9 is only a multiple, will always be more or equal to 0. Because of that, we have shown it will never be negative. Let's move on to the next question. So part 1, we have to sketch on a single diagram the graph of cos y equal to cos 2 theta and y equal to this one. This one is pretty easy. As we can see, y equal to a constant value is just a horizontal line at the value of y equal to half. And this is your curve cos y equal to cos 2 theta. Now one by one, obviously, y equal to cos 2 theta. Now obviously for this kind of graphs, I will first advise to make a table of values. Now theta is between the value of 0 and 2 pi, so first begin with theta, and here we have the corresponding value of y. Now, because here we have 2, what interval can I choose? I will begin with 0, obviously, because that is my base value right here. So what interval can I choose for this table? Because here I have 2, I'll have to take 90 divided by 2. That should be 45 degrees. That will be 45, which is pi by 4, 45 pi by 2, 45, which is, you keep adding on, 1 over 4. That should be 3 pi by 4 plus 1 over 4. That should be pi, and then should be 5 pi over 4. That should be 3 pi over 2, and finally 2 pi. So the reason why we choose this interval, or I choose this interval, is because I like to work with exact values of y on my graph. Now, when theta is 0, here we have to use radians. Cos of 0 should be 1. Cos of 2 times this should be pi over 2. That should be 0. And here we have pi over 2 times 2 should be just pi. Should be minus 1. And this one should be what? 3 pi over 4 times 2 should be 3 pi, sorry, that should be 3 pi over 2. So cos 3 pi over 2. That should be 0. And then pi should be cos 2 pi should be 1. As you can see, there's a cycle. 1, 0, minus 1, 0, 1. So again, next one will be 0. Next one, minus 1. And back to the value of 0. So I think I'm missing a value here. Let's check. We have what? So 45 plus 45. Sorry, 0 plus 0 is my answer. Plus 45 should be 45. 90, 135, 180, 225, 270, 315. So I'm missing a value here somewhere. 315, and then I will have 360. So I'm missing a value. So let me check. So that will be 5 times 180 divided by 4. That should be 225 plus 45, 270. That should be 3 over 2 plus 1 over 4. That should be, I'm missing one value here. So let's call this one. So 3 pi over 2 plus 1 over 4 pi should be 7 pi over 4 and then 2 pi. So you have to always end up with a complete cycle here as 1. So I did realize I was missing a value by trying to understand we have to have 1 cycle and 2 cycle. Now we know this shape. Now we can simply sketch the graph. For example, now if you guys don't understand this trick, we can always write down the values and replace back in your calculator to find the corresponding values as easily as that. Now let's sketch the axis. Now again, I will advise to use a ruler here. That will be x value and that will be y value. Now here we have 0. Here we have pi by 4. Pi by 2, 3 pi by 4, that should be pi by 4 by 2, and that should be 2 pi. That is the value of 1 and minus 1. So first point is 0, 1 should be here, that should be here, and that should be 0 and here. We have this and this. Okay, so again, if you use a ruler here to make this kind of straight line, and straight line is the best for you, but again, it's only a sketch. I'm trying my best just to freehand this. That should be something like this. Okay, at the end, just label your graph as y equal to cos 2 theta. And the next step is to draw the other one, which is y equal to half. Pretty easy. Half is right here. And we understand that y equal to a constant, it is a horizontal line. We just have to draw a horizontal line. That will be this right here. That will be y is equal to half. That will be part 1 of your question. Now let's move on to part 2 of your question. Here we have to write down the number of roots of this equation. So pretty easy. If you observe, we have 2 cos 2 theta minus 1. So cos, that is 0 here. Cos 2 theta is equal to half. Now we can see cos 2 theta is one of the graph. Equal to half is the other graph. So where are they equal? By observation, you can see they are equal at this point, this point, this point, and this point. Because they meet at 4 points, we can conclude the number of roots have to be 4. Now for part 3, deduce the number of roots from the equation this in this interval. So pretty easy. Now we understand that from this interval, so from 0 going to 2 pi, we have only 2 pi. Number of roots is 4. But now from 10 pi going to 20 pi, we have the domain of 10 pi. That should be 4 divided by 2 times 10. That should be 20 solutions. By using a ratio, that will be 20 solutions we will have in this domain. That should be 20 as your answer for question part 3. A function f is defined by x equal to any real values and is such that f prime of x is equal to 2x minus 6. Now we have to know f prime of x is simply dy by dx. Right. Now the range of the function is given by this one. That's the range of the function, which is the y values of the function, always going to be more than the value of minus 4. Great. Now what else? So part 1, state the value of x for which f of x is stationary, has a stationary value. So we know this is true when dy by dx have to be 0. So equate x will have to be 3. So the value will be this one. Now what else? We have to find an expression for f of x in terms of x. So pretty easy. F of x is simply integration of f prime of x, right, with respect to dx. So that will be 2x minus 6 dx. That will be 2x squared divided by 2 minus 6x plus c. Now simplify, that will give you what? X squared minus 6x plus c. This is obviously f of x. We have to find the value of c. We have to use a passing point. For example, here I know the value of x here is 3 for the stationary point. Let's find the corresponding value of y. Or we cannot find this yet because we don't have the curve yet, right? So let's see what can we do. So when x equal to 3, we know that dy by dx is 0. That's something good to know. And what else can we use here? So we have the function, the range of the function is given by this. So if that is the range, so it means the value of x will always be more than 4. That's the minimum value for the function. Now, can we use that somewhere to find the value of c? Let's think. So we have to kind of look at the graph to understand what's happening for this information. So again, I know it is a kind of a weird way to represent, to use that information, but if you understand what's happening is, what is the range? Again, range is the y value. For example, here, our graph, it tells you that the range will be always more than 4. So for example, I know that my graph has a stationary point with this one. As you can see here, the coefficient is 1. It will have a shape something like this. Right. Now we know it will have a minimum point. But given the graph is always more than the value of 4, I understand that this value here will be, say, minus 4, because it's always going to be more or equal to that value, which makes it our minimum value. Now this happens when x equal to the value of 3. So the minimum point is actually 3 minus 4. So we have to use that to find the value of c. This is the x value, the y value. Replace y is simply f of x, so that will be minus 4 is equal to 9 minus 18 plus c. So simplify. 9 minus 18 should be this, and then minus 4 plus 9 should be 5. So C will be the value of 5. So finally, f of x is equal to x squared minus 6x plus 5. And that will be your equation of f of x in terms of x. Okay, so let's move on to the next question. The diagram represents a metal plate OABC, so OABC, great, consisting of a sector OAB of a circle center O here, OAB, radius, and the angle is theta. Now, and we have radius R together with a triangle OCB on top, which is a right angle triangle at C. Good to know right here. And the angle AOB is theta radians, and OC is perpendicular to OA. OC is at 90 degrees to OA. So which means this have to be 90 minus theta. Anyways, let's move on. So part 1, we have to find an expression in terms of R and theta for the perimeter of the plate. So how would you find the perimeter of the plate? So pretty easy. We have to find the distance around the plate. So by observation, P will be OA plus AB plus BC and plus CO will be the distance around the plate. Now OA is simply R, AB is arc length, which is R times theta, plus BC is this one. So how can you find this one? So let's observe. We can find this by using the I think SOHCAHTOA, because we have a right angle triangle. This is my A side, right? This is my H side, so we can use cos. Cos of the angle will be what? Will be the A side will be, we don't know, which is BC over the value of R. So BC will be R cos theta. R cos theta. So BC is R cos theta. Now what is the value of CO? CO is this one. So again, we can use SOHCAHTOA. Here we have the opposite side, and here we have H side. We can use sine. Sine of theta will be the opposite side, will be this one, CO over the value of R. So CO will be R sine theta. So finally, the perimeter is R plus R theta plus R cos theta plus R sine theta. In terms of R and theta, there you go. That will be part 1 of your question. If you want to factorize, you can also factorize the value of R outside. Now for part 2, for the case where R equals to 10 and theta is 1 over 5 radians or pi radians, find the area of the plate. So the area can be found pretty easily as well into 2 pieces. We can first find this area, then add this one to find the area of the plate. So number 1 is pretty easy. Number 1 is area of a sector, which is half R square theta, 1 over 5 this. So half times 100 times 1 over 5 pi. That should be 31.4159. Okay, now for number 2, it is also pretty easy. It is area of a right angle triangle. So we know this, we know this as well, which is R sine theta. Right. Now, how do you find area of a right angle triangle? We can use half times base, R is 10, cos theta, 1 over 5 pi, and times height, which is 10 sine 1 over 5 pi. Simplify. So now we have to use radians, obviously, half times 10 cos pi over 5 plus, so times 10 sine pi over 5. That will be 23.8. Correct to 3SF. So that is part 2. So you add them together, the area of the plane should be this plus this, 31.4159, that should be 55.2, correct to 3SF, the area of the plate. Okay, and that will be part 2 of your question. Okay, so let's move on to the next question. The sixth term of a AP is 23, so sixth term. And the sum of the first 10 terms is the sum of the first 10 terms is 200. We have to find the seventh term, T of 7. But now we already know the type of progression we have. It is an AP. So we can write down all the formulas we know about the AP. So we know that the nth term is given to you by A plus n minus 1 times D. sum of the first n term is half n times 2a plus n minus 1 times d. So we have to use the two given values and form two equations. First one is this. T of 6 is 23, so 23 will be a plus 6 minus 1 is 5 times d. Equation number 1. Here we have sum of the first 10 terms is 200, so again that will be 200. Half 10 terms is 10 here, and we have 2a plus 9d. Now we can simplify, obviously that should be 10 goes away. Then we have 2, that will be 40 is equal to 2a plus 9d. My equation number 2. Now here I can make a become subject, so a will be 23 minus 5d. Replace back in here, you will have 40 is equal to 2 times a, that should be 46, minus 10d plus 9d. That should be minus 6, and that should be minus d, so d will be the value of 6. So finally, the value of a, we replace back here, 23 minus 30 should be minus 7. So a is minus 7, and d will be 6. However, the question here is asking you for the 7th term, so 7th term replace back in your equation, that should be a plus n minus 1 will be 6 times d. That should be minus 7 times 36, sorry, minus 7 plus 36, that should be 29. That will be my 7th term. Okay, that will be part 1 of the question. Now for part 2, a GP has its first term 1, so a is equal to 1, and the common ratio, common ratio is just r. Now a second geometric progression has a first term of 4 and common ratio 1 over, okay, good, we have 2. So again, for the GP, what do we know? The n term is given to you by a r n power 1. Sum to infinity should be a over 1 minus r. Now, we know we have two types of, not two types, but two GP. The first one, we have the first term is 1 and common ratio is r. Second one, we have the first term is 4 and the common ratio is 1 over r. Now, the two progressions have the same sum to infinity. Find the value of r. Now, it gets pretty easy. For the first one, let's call it S1. Sum to infinity should be a 1 minus r. For the second one, should be a 1 minus r. So we know they are equal, so we have to equate them to each other. So on one side, this is equal to 4 over 1 minus 1 over 4. So now we can try to, let's see, how can we solve? We can try to cross multiply. This will go up and this will go up. You will have 1 minus 1 over 4 r, and that should be 4 minus 4. Now we can send this over here and this over here, that should be, so minus 1 over 4 plus 3, that will be what? Minus 1 over 4 plus 4, sorry, not 3, that should be 3 over 4r is equal to the value of 3. So r will be 3 divided by answer, that should be 4 over 5. So r will be this value. So let's find the value of a. Replace back in your equation. A we know already, as you can see here, right? Find the values of r and s. So we have to find the sum to infinity. So replace back in your equation. Sum to infinity, 1 over 1 minus 4 over 5. So 1 divided by 1 over 5. That should be 5. So sum to infinity is 5, and the value of r is equal to 4 over 5, and that will be part 2 of your question. Now let's move on to the next question. The diagram shows the dimensions are in meters of the L-shaped garden. Now the perimeter of the garden is 48 meters. Now again, what does that mean? It means the distance around the object is 48. So how would you find that? So the perimeter is 48, so how would you find it? You would take x plus this, so x plus 3y plus 4x plus y plus 3x plus 2y is supposed to give you 48. So we can form an equation right here that will give you what? X plus 4x is 5x plus 3x is 8x. 3 plus 1 plus 2, that should be 6y is equal to 48. Okay, now express y in terms of x, so y will be 6y will be 48 minus 8x. So y will be 48 minus 8x divided by 6. Now obviously we can simplify divide by 2 everywhere. You will have 24 minus 4x divided by 3. That will be y equal to this. Now for part 2, given that the area of the garden is A, so the whole thing here is A, we have to show this. So how would you find the area of the garden? So pretty easy. We can break this down into 2 pieces. If you, by observation, we can continue this down. Now we can see the area of the garden is simply 2 areas. The area number 1 here, area number 2. So how would you find area number 1? Length. So length times width. This is 3x times width. Area number 2, it is length, which is 3y times width. So this is the area of the garden. 3xy, y is 24 minus 4x over 3, plus 3x times y, 24 minus 4x over 3. Now simplify, these two will obviously cancel out. Oh, they're the same actually, so these two, so they're actually the same. As you can see, this is the same, that will be 6xy. Right, so I guess that was more simple than I thought. So I will combine, that should be 2x times 24 minus 4x. Expand, you will have 48x minus 8x squared. This is shown as required. Now next one. For part 3, given x can change, find the maximum area of the garden. So if we define the max or the mean value, we have to look at dA by dx is equal to 0. So let's first find dA by dx. That will be 48 minus 16x is 0. X will be 48 divided by 16. That will be 3. Now replace back in your equation to find the area at this value. That should be 48 times 3 minus 8 times 9. So 48 times 3 minus 8 times 9, that should be 72. This is the maximum area. Of course, you have to write this as the unit as well for the area, showing that this is the maximum. How do you show that it is maximum? You have to find the second derivative, which is d2a by dx2. That should be minus 16. So you write, since d2a by dx2 is less than 0, we prove that the stationary value of a, which is this one, is a max value. Because it is negative, it will be a max value. So pretty easy, step by step. First thing first, you have to find the max area. To find the max area, we first have to find dA by dx, because that is the stationary value. Then we have to find the value of x, but afterwards we place x back in a to find the value of a, which is this, part 1 of your answer. Then to show the maximum or the nature, we have to find this one and then show this one. Okay, that will be part 3 of your question. Okay. So let's move on to the next question. Relative to a point O, we have the point A has position 4i plus 7j minus pk, and point B has a position vector of 8i minus j minus pk, where p is a constant. So we can rewrite this as what? OA is equal to 4, 7 minus p, and OB is equal to 8 minus 1 minus p. So now we have to find the dot product of those two vectors, so pretty easy. On one side we have 4, 7 minus p dot of 8 minus 1 minus p. So this will be 32 plus minus 7 plus p. That will be what? 32 minus 7 should be 25. So 25 plus p will be your answer for part 1 for the dot product of those two vectors. Now for part 2, hence show that there are no real values of p for which this and this are perpendicular to each other. So what does that mean? It means that if, so this is actually p square, right? So p, that should be p square, my apologies. So if they were perpendicular to each other, we understand that it will be this dot this will give you 0. So let's equate. We will have 25 plus p square equate to 0. Let's rearrange. We'll have 20 p square plus 0 p plus 25 equal to 0. Now again, we want to show they have no real values of p. We have to look at what? For the real values of p, we have to look at b square minus 4ac is what? Let's see what does that give us, right? So here we have a, b, and c. B squared is 0 squared minus 4 times a times c. That should be minus 100. So you can write, since b squared minus 4ac is less than 0, which is negative, it has no real solutions. That's why, right? So, and what does that mean? For example, let's say if you were to solve this, let's say if you were to solve 25 plus p squared equal to 0, p squared will be what? Will be minus 25. So p will be plus minus root of minus 25. Now if you were to perform this, root of minus 25 is error, because it is not a real solution. It will be in the imaginary solution part. So again, we have to show this one here to show there is no real solution. Now for part 3, we have to find the values of p for the angle is this. So pretty easy. We are given that the angle AOB is 60 degrees, but how would you usually find the angle? So we understand that the formula is actually OA times OB equal to the magnitude of OA times the magnitude of OB and cos of the angle, right? So this we know already, it is 25 plus p squared, and this is the magnitude of OA, pretty easy. That should be 4 squared 16 plus 49, that should be root of 65 plus p squared times root of 64 plus 1, that should be 65 plus p squared, cos of 60. Now cos of 60 is what? It is half. We can check. Cos of 60 degrees should be half. Good. Now what else? We can try to simplify. Root of the same value inside will cancel out, right? It will become what? 25 plus p squared is equal to 65 plus p squared times half. I hope that makes sense. For example, here let's say if you had root 2 times root 2, what is that? It is simply 2 power half times 2 power half, because they have the same base. You can combine the top together. Half plus half will be 2 power 1. So the value inside, we take inside and power 1. So inside power 1 will be this one. This is how you will simplify this. Now what else? Let's see. We can multiply by 2 or cross multiply. Right, 2 goes here, you have 50 plus 2p squared is equal to 65 plus p squared. Send this over here, you will have what? That will become p squared is 65 minus 50, that should be 15. So finally p plus minus root of 15. So these are the values of p for which the angle is 60. And that will be part 3 of your question. So let's move on to the next question. A line has equation y equal to kx plus 6, and a curve have equation y equal to x squared plus 3x plus 2k. Okay. Now part 1. For the case where k is equal to 2, the line and the curve intersect at the point A and point B. Find the distance of A and B and the midpoint of AB. So let's see. If this is 2, you will have y equal to 2x plus 6 and y equal to x squared plus 3x plus 4. Now the points of this intersection is obviously we have to solve simultaneously. So on one side you will have this and you will have this on the other side, because y is already subject. Now we have to rearrange. Send this over here. You will have x squared, 3x minus 2 is plus x, that will be minus 2 is 0. Now we can factorize. That will be x times x, 2 is 2 times 1, plus 1 is plus 2 minus 1, right? To get, now again, if you don't know how to factorize, you can always use your formula to find the values of x. X will be minus 2, x will be the value of 1. Let's find the corresponding value of y. Replace back in your equation. So 2 times minus 2 is minus 4, plus 6 should be 2. Here we have, that should be 8. So the point A should be minus 2, 2. The point B should be 1, 8. Now the midpoint is pretty easy as well. That will be x1 plus x2. So that will be minus 1 divided by 2. That will be this. x1 plus x2 should be 10. That should be 5. So this is the midpoint of AB. Now for part 2, we have to find the two values of k for which the line is a tangent to the curve. Okay. Now we have to understand, if the line, this is the curve, if it is a tangent to a curve, it means they meet at only one point. Now if it is only one solution, we understand we have to look at b squared minus 4ac equal to 0. So let's solve. So you would have 2x plus k on one side and x squared plus 3x plus 2k on the other side. Now again, rearrange, you will have x squared, so plus, that will be x, right? And 2k minus k should be just plus k, is 0. Now this is a, b, and c. So b squared is 1 squared minus 4 times a times c. Have to be 0 because they meet at only one point. Now let's see what are the values of k can we have. Let me check. So here we have what? Find the values of k for which the line is a tangent to the curve. So we have this and this. Okay, fair enough. Replace, okay, I see the mistake here. This is supposed to be k, right? And this is 6, not this one. Okay, I guess that's a pretty silly mistake, so be careful when you replace your values. That should be x squared, and that will be 3x. Let me rewrite this now because this is wrong. That will be x squared, 3x minus kx, and here we have plus 2k minus 6 is 0. Now we can factorize, obviously. You have this is 1 plus 3 minus k x outside, and here we have 2k minus 6 is 0. That is a, b, and c. Now b squared is 3 minus square minus 4 times a times c equal to 0 because we know it has only one solution. Now let's simplify. You will have 9 minus the value of 6k plus k squared minus 8k plus 24. Simplify. That will be what? K squared minus 14k. That should be plus 33 is 0. Now we can try to factorize. K times k. 3 times 11 is 33. To get minus 14, we have to have minus 3 minus 11. So the two values of k will be what? K will be the value of 11 and k will be the value of 3. So these will be the two values of k for which the curve is a tangent, for which the line is a tangent to the curve, which means they have only one solution or one point of intersection, and because of that we have to look at b squared minus 4ac equal to 0. Now let's move on to the next question. The diagram shows the curve y equal to this, so now we can rewrite this equation as m1 plus 2x power half, right? Because root is simply power half. Next step. Now it meets the x-axis at the point A, so let's find the point A. So at the x-axis, what do we know? The value of y has to be 0, so that will be 0 is equal to 1 plus 2x power half. Now we can square both sides, that will be this, and this will cancel out obviously, right? And 2x will be minus 1, x will be minus half. So this is the point here, is minus 0.5. The point A will be minus 0.50. Now what else? And the y-axis at the point B, so we can find the point B as well. So at the point B, on the y-axis, the value of x will be 0. Replace, you will have y is equal to root of 1. That should be 1. The point B will be 0, 1. Point A, point B found right away. Now, the y coordinate of the point C is 3. So the y value here, let me so here we have a point C. The x value we don't know, but the y value of the point C is 3. Okay, so here we have this value, and here we have the value of 3. So how would you find the x value? Pretty easy. Since C lies on the curve, just replace y by 3 and solve for x. So let's do this. So we have y is 3. That will be root of 1 plus 2x. That will be 9 minus 1 plus 2x. That should be 8, and x will be the value of 4. So here you go. The point B is the value of 0, 1, and the point C is the value of 4, 3. Okay, that will be part 1 of your question. Now for part 2, find the equation of the normal to the curve at C. So again, to find the equation of the normal, we have to first find the gradient of the normal. But we understand that the normal and the tangent, they are at 90 degrees to each other. So we can first find the gradient of tangent, and then we can derive the gradient of normal. So now we know by definition, the gradient of tangent is simply dy by dx. That will be what? So let's use this. First multiply by the power, half. 1 plus 2x, then minus 1, that should be minus half, times d by dx of the inside value, that should be 2. Simplify, that should be 1, 1, cancel out. 1 over 1 plus 2x power half. So that will be my gradient of tangent. Now at the value of c, at the point c, right? So at the point c. So let's find the value of this at the point c. Point c, x value is 4. Replace 1 over. So 2 times 4 is 8, plus 1 is 9, square root is 3. So the gradient of tangent is 1 over 3. From this we derive the gradient of normal will be minus 3. Because we have to know this relationship is minus 1, right? Because they are perpendicular. Now we have this one, we have the passing point as well, which is c. We can find the equation of the straight line pretty easily. So x value, y value, so y minus its corresponding value, x minus 4 have to be equal to minus 3. So this is just a method that I use to find the equation of a straight line, but you can use your method if you want to. So cross multiply, you will have what? Y minus 3 is equal to minus 3x plus 12. Y equal to minus 3x plus 15. That will be equation of your normal at the point C. Now for part 3, we have to find the volume obtained when the region is rotated about the y-axis. So pretty easy. Now since we understand it is going to be about the y-axis, so volume about the y-axis is equal to this integration of x squared respect to dy. Now we know that x, so we know that y is equal to 1 plus 2x power half. We have to make x become subject, so let's do that. So first we can square both sides. You will have y squared is equal to 1 plus 2x. 2x will be y squared minus 1. From here, x will be y squared minus 1 over 2. So now x squared will be what? Just square those values. You will have pi limits. X squared will be y squared minus 1 square over the value of 4 respect to dy. Now what are the limits? By observation, we know this is 0. And this is what? B is the point 0, 1, that should be 1. Limits is 0, 1. So 1, 0. Now we can simplify, obviously. On top we can expand. You will have y squared, that should be y4 minus 2y squared plus 1. We take out the value of 4 outside. It is only a multiple. And integration of 1, 0 respect to dx. Now we can simplify. This is only the multiple outside, and inside we will have y power 5 over 5 minus 2y over 3 over 3 plus, this is y here, plus y. That should be 1, 0. That will be pi over 4 times this will be 1 over 5 minus 2 over 3 plus 1. And the next obviously will be everything will be just 0. So 1 over 5 minus 2 over 3 plus 1, that should be 8 over 15. 8 over 15 times 1 over 4, that should be 2 over 15. That should be the volume of that region when we have a rotation about the y-axis. Let's move on to the next question. Functions f and g are defined by these two. Right. Now we have to be careful here. The domain is between 0 and 2. And here also we have 0 and 10. Now part 1, we have to express f of x in terms of this. So we have to complete the squares. So let's try this. First thing first, we have to make the coefficient of x squared become 1. So factorize by 2. You will have 1 minus 4x. And we can just leave this one outside. So now we can proceed to the next step. So first we have to add something. Take the value here will be 4. Divide by 2, square. Now when you add something, you also have to minus the same value so you don't change the equation. Because it was inside of the bracket, we also have to give it the value of 2. That will be 2. That will become x. Here we have minus. Inside become 2. And that will be square. So this whole thing here becomes this. Now plus 10. Here we have 2 square is 4. 4 times 2 is 8. 10 minus 8 will be plus 2. That will be part 1 of your question. Now for part 2, we have to state the range of this. So let's see. Because we know the complete square form of the curve, we understand the value at the end is the minimum value. So your curve usually will have a shape of this. And the minimum value here will be this value, y is 2. As you can see, the curve will always be more or equal to this value. However, we have been restricted by this domain. Let's see what is the value of y between those two values. So when x equal to 0, what is the value of y or f of x? Replace back here, you will have 2 times 0 minus 0 plus 10. That was 10. So that was 10, sorry. And when the value is 2, as we can see, y will have to be 2 as well. So you can see the limit is between this one. So f is between the values of 10 and 2 because of the restriction we have for the x values. Now from here we have to state the domain of this. So pretty easy. We understand the domain of f inverse is equal to range of f. So but how would you describe the domain? It is the x value, so replace f by x. That will be same this and this. That is part 3 of your question. Now for part 4, sketch on the same diagram the graph of this, the graph of this, and the graph of this. So pretty easy. So at first we have y equal to f of x is 2x squared minus 8x plus 10. Now we have the y-axis and we have the x-axis. Right. This is x and this is y. Now the value of x is between 0 and 2, so let's mark that. We have 0 and the value of 2, let's say it's here. So we know when x is 0, the value of y is 10, and when x is 2, the value of y is 2. So your graph is something like this. It is a minimum curve, right? Because the coefficient is positive, it will have a minimum shape. Now this is the graph of y equal to f of x. Now we understand the graph of g of x is just x, which is y equal to x. That will be a line passing exactly right here. Right? That will be between the value of 0 and 10. So we have to remove this part only for 0 to 10. So we have to continue until 10, if that makes sense, right? That will be y equal to g of x. And then finally, for f inverse, we understand it is a reflection along this line. So let's try your best. That should be what? So let's see, that should be somewhere. So here we have half plus 2. Half plus 2 should be somewhere over here. When this will be value over here. Just kind of make them meet over here as well. Okay, and that should be your graph of, label this as y f inverse of x, and that should be y equal to f of x. So in this case I will have to remove this part. Why? Because g of x is only defined for the values of x between 0 and 10. You have to also mark 10 somewhere over here to show that you will continue the line up till 10. Okay, that will be part 4 of the question. And what else? We have to find the expression this. So pretty easy. First thing first, we have to let y equal to f of x. So let y equal to f of x. F of x is the value on top. We have 2. That should be y minus 2 divided by 2 should be x minus 2 this. So x minus 2 should be plus minus y minus 2 over 2. So which means x have to be 2 plus minus y minus 2 over 2. So finally we have f inverse, which is in terms of x, that will be 2 minus x minus 2 over 2. Again, we choose x here because we can see the domain have to be less than the value of 2, right? For this one, f less than 2, less than 2. Okay, so that's why we will have to choose the minus sign for f inverse. That will be part 5 of your question.